Okay, so this if is this the way y'all want to graph the line? Is using y equals mx plus b?
Yes.
I'm okay with that. Okay, but we got to know what it's called, and you're gonna need a refresher because just listening to you try to explain it, y'all need a refresher from that. But it's okay. I like graphing it that way. That's the way I would graph it. So this is called slope intercept form. Now, why do we call it slope intercept form?
Because it's got slope. Because the base the slope.
Okay. Not quite. So we call it slope intercept form because it's easy to identify both the slope and the y-intercept. So we call it slope intercept form. So let's talk about what both of those things are. When I talk about slope, what is the slope of a line? Like, what's that talking about? It's the rise over run. I like that. She did. Oh, did one of y'all say it over there?
I was talking to Brody. I wasn't talking to him.
Okay.
He was like, oh, you do. I didn't know.
Okay. What else is slope? Like, when I look at a line, how can I tell how slopey it is?
If it's not flat or up and down, it's slanted.
So we talk about that like steepness, right? Like, think about on a roof. You think about a steep roof versus a not as steep roof. This steeper roof has greater slope. That's literally what they call it. The slope of the roof. So the steeper it is, the more up and down. So that means it has greater slope. The flatter it is, that has less slope. We also have negative slopes, right? Where it goes down from left to right. So what slope tells us is how slanted or how steep the line is. How steep line is. Okay, in this equation, what is my slope? What letter represents the slope? Wrong. The M. Okay, so again, you need to write these notes because we're just listening to us. We're not great at it. Okay, because we don't know which one's slope, which one's y-intercept. So that's why I'm doing this refresher. Slope, how steep is the line? It's represented by an M. Okay, next. The other part of slope intercept form is the y-intercept. Okay, what is our y-intercept? What does that represent?
B.
It is the B, but like on a graph, what does y-intercept mean?
Where it intercepts the y-axis.
Yes. The y-intercept is where our line crosses the y-axis. Same deal, intercepts, whatever you want to say. I use crosses because I'm from Sand Mountain. So, which one of those do we have to use first when we graph a line? Do we use the slope first or do we use the y-intercept first? Why? Because? Okay, another word for slope is the rate of change. Have you heard that? So what does rate of change mean? Yeah? Okay, yes. Yes. How much something's changing by. So the slope measures how much I'm changing from point to point. So in order to use it, what must I have? A point. You can't use slope until you know a point. So the only one of these that is a point is y-intercept. It's a point where we cross the y-axis. So I have to go to that point, put it down, and then use the slope to find how much am I changing to get to the next point. Okay? So make sure, again, the reason I'm going through this is because I've seen all the things that you've talked about. I've seen people try to put the slope first. All right? Which you can't do. That's going to make you miss the line. I've seen people not know what a y-intercept is. That's why I'm reviewing. Okay? Not just your class. That's been pretty much every class I've taught in math since I've started. Okay, so that's a good refresher for us. So if I've got, what is the graph of the linear equation y equals 2x minus 3? So I can see this is already in slope-intercept form because the y is by itself, and then I have no parentheses. Right? Those are two things that I look for to make sure I'm in slope-intercept form. Y is by itself and no parentheses. So now, looking at this, what is my slope? What is my m? My slope? 2. Which we can write as 2 over 1, absolutely. It's going to be beneficial to write that as a fraction when we get to graphing it. Now, secondly, what is my y-intercept? Negative 3. Remember, the sign in front of that number goes with it. So this tells me I cross the y-axis at negative 3, then I rise 2 and run 1 to find other points that are on my graph. So if you have graph paper, this will probably be a good use of it today. If you don't have graph paper and you would like to use some, I have some in this top drawer. If you want to go get it, I'll give you. Okay, so here we go. Let's graph this. So again, I have to begin with a point. I know the point that is the y-intercept. I cross the y-axis at negative 3. That means I go on my y-axis to negative 3, and I plot that point. Okay, I like that one. Now, from this point, I use the slope to find more points. So from here, if the slope is 2 over 1, that means I can rise 2, run 1. Because my run is positive, that means I'm going to go right. So that would be right here at negative 1, 1. That would be another point. Now, how many times can you rise and run? As many as you want. You have to have at least 2 points, but if you are a very sloppy drawer like I was in high school, the more points the better. So I would rise 2 again and run 1. Rise 2, run 1. Rise 2, run 1. Okay? Now here's a little tip or a trick that you might know or you may not know. If I can go up and to the right, I could also go down and to the left. I could treat this as negative 2 over negative 1. I can make them both negative. So again, I could go down 2, left 1, and you see how that's still in line with my other points. Once I get enough points that I feel good about it, I'm going to connect those points, and I have created the graph of my line. Now what we're working on here is we are working on picking points that make the equation true. So let's pick a point here that's on my line. We should have the point. Right here was a point. Let's see. So I'm going to pick that. That's the point 3, 3. Okay, now what does it mean if this point is on my line? It means if I plug in 3 for x and 3 for y, this should make a true statement. If it does not make a true statement, then it's not a point that is on that line. So let's say y, which is 3, equals 2 times x, which is 3, minus 3. Now let's see if the right side simplifies to give me 3. 2 times 3 is 6. 6 minus 3 is 3. So you see how 3, 3 was a valid point. It worked. And it was also a point that my line went through. Do we understand that? Lines are just collections of points that make this equation true. So I just picked 3, 3, but I could have picked any point on that line. Like I could have picked the point, let's see. Right here I had a point. Right, this is -1, -5. If I plug those values in, I should get a true statement. Any points on the line should make a true statement. So what I want you to do, I want you to pick a different point and verify that it's a solution. That's your try your example. So don't pick 3, 3, pick a different point. If you want to pick -1, -5, you can. Right? What are the points that we had? We had a point here. We had a point here. And these are just the nice points we picked, right? There are also points that are in halves. Like if you wanted to, you could pick this point. This point is 1.5, 0. That should make it true. Right? Anywhere that's a point on that line should make our equation true. And I want you to verify it by plugging it in. Basically what a vertice, not necessarily the highest, it will be in the triangle I'm drawing here. So basically a triangle is made up of 3 lines, right? Well, the points where the lines meet each other, so we've got a point there, and a point there, those are called the vertices. It's where the 2 line segments intersect with each other. So, it is the top on that one. But that's just because I drew a triangle that's at the top. I could draw a triangle that doesn't have a highest point. Do it? Well, now then there's 2 at the highest, right? They're the same. Or you could turn it like this. Anyways, the vertices are where those line segments meet. So it says the vertices of a triangle ABC are formed by the intersection of the graph of the equations, and then we're given 3 different equations. We want to know what are the coordinates of the vertices. So what they're asking is where do all of these line segments meet on the graph? So in order to do this, you have to be very careful when you are graphing. So let's see, we're going to graph first. We've got y equals -1/4 x plus 1. So my y-intercept is +1. So I go to +1 and I plot my point.
Well, you couldn't you either go left point up 4, right point, and down 4?
Okay, so since the slope is -1/4, we have a decision. We can put the negative up top, or we can put the negative on the bottom. Either one. So if I put it up top, that means I'm going to go down 1 to the right 4, which would put me here. Or if I did it the other way, I could go up 1, left 4, which would put me here. And so right here I have my first line. Oh, goodness. I am not good at drawing lines. You guys will see very quickly. Okay, there we go. There's my line.
You can do the same thing.
Okay, now the next one. The y-intercept is 6. And then my slope is 1. Yes, so I would go down 1 and right 1. Down 1, right 1. Oh, no. So these are going to meet off the graph. That's not good.
It works if you went the other way. To the left, don't meet up.
If I go left and down?
If you go left or down one left one.
Well, I can't go down and left. That would be a -1 slope. If I went up, I'd have to go to the left. Up and left.
That one must not work.
Hold on. You've got me all messed up. I did my line wrong.
What?
It's your fault.
Mine?
Yeah,
How's it my fault?
because you told me to go down 1, right 1. And I just listened like a dummy, like I'm not even the teacher. Okay, my y-intercept is 6. Now the slope is 1, which I can write as 1 over 1. So I could go up 1 to the right 1, but that's going to take me off the graph. Or I could go down 1 to the left 1. They should both be negative.
That's what I said.
I should have been listening. That's my fault. So if I go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Yeah, that's exactly what you said. Thank you, Shoemaker. There is my blue line, the second one. And now my green one, y equals -3 over 2, x plus 6. So its y-intercept is also 6. So I found a point where they meet, right there. And if the slope is -3 over 2, then I'm going to go down 3 to the right 2. Down 3 to the right 2. Down 3 to the right 2. And so when I draw that line, I am right here. So now if I want to find my vertices, I'm finding the 3 places where my lines intersect. So they intersect here, and there, and there. Those are my 3 vertices. So they want to know what are the coordinates of these vertices. So let's start here. So what are the coordinates of the intersection here? So like what's the ordered pair?
First one at the bottom right corner is 4, 2.
Okay, this one here should be happening at 4, 0. Right, I go right 4, and then I go up or down nowhere. So the coordinates there are 4, 0.
The one on the left is -4, 2.
-4 and 2, I agree. Because I went left 4, up 2.
0.
Remember, you put your x value first.
I was just gonna see if I can mess them up.
I got you. Well, you've already messed me up, so we're good. All right, so the x value is 0, y value is 6. So my 3 vertices are listed here. 4, 0, -4, 2, and 0, 6. So what do you think are some problems that could happen finding vertices this way? Like why could this be a bad way to do vertices? Don't know? What if the place that they meet is off your graph, like we almost had, right? That could be a problem. What if the place that they meet is a fraction or a decimal and it's a real ugly number? Are you going to be able to tell what it is by just looking?
No.
No.
You know, a quarter, a half.
You'd have to kind of guesstimate, right?
Yeah.
Which is not great. So graphing to find vertices is valid and it works, but we also had to be very careful about how we graphed it, right? What if my lines were a little crooked, a little slanted? What if my graph wasn't to scale? I mean, there's a lot of problems we could have, right? So we're going to do another example where you graph this way using vertices, but then the next example, we are going to show a different way to find vertices that does not involve graphing. Okay, so hopefully everybody has the first line graph by now. If you don't, I'm going to go ahead and put it on the board. So my y-intercept should be positive 4. So I should have it crossing the y-axis there at 4. Then I use 3 over 2 to find the next point. So I would like to go up 3 to the right 2, but I can't go up 3. It takes me off my graph. So instead, I'm going to go down 3 to the left 2. So down 3, left 2. There's a point. And then we go down 3, left 2. And I can even do that one more time. Down 3, left 2. And so this is what your first line should look like. Okay, now sometimes they won't meet in exactly the right place, but all these should. So you may have, just watch what I do. You may have missed a line, or maybe you didn't draw your lines real straight, one or the other. But they all should meet on this problem. But in some problems, you're right, they don't. And that's bad. As you can see, I'm not a very good drawer either, so. Okay, let's look at the next one. 1/2 x plus 2. That means I should go up 2, plot my point. And then from here, I'm going to use the 1/2. So I go up 1, right 2, up 1, right 2, up 1, right 2. Okay, that's not all great. So let's go down 1 and left 2. Now I see where those meet. Down 1, left 2, down 1, left 2. And so the second line should look something like that. Again, that was pretty bad. Let me try it again. That's why I told you I draw as many dots as possible, because I do not draw very straight lines. It's not one of my strengths. Then the last one, negative 1/2 x plus 4. That means I'm going up to positive 4, plot my point. Then I'm going to use the negative 1/2 to find my next points. So I go down 1, right 2, down 1, right 2, down 1, right 2. Or I could go up 1 and left 2, up 1, left 2. And then I connect those points like so. And I now have my triangle. It's right here in the center, right? It's a pretty small triangle, but it's right here. Now my 3 vertices are there, there, and there. So now what are the coordinates of all of those vertices? Well, the far right one here, you should have gotten coordinates of 2, 3. This one here has coordinates of, should be negative 2 and 1. Right, we went left 2, up 1. So it should be negative 2, 1. And then up here, these coordinates are 0 and 4.